Hey everybody, and welcome to another episode of React Roundup. This week on our panel we have Lucas Heiss.
Hello everyone.
We have Justin Bennett.
Hey folks.
I'm Charles Max Wood from devchat.tv. Another quick reminder, go check out the DevRev. I did take a week off for Thanksgiving, so it's not that hard to catch up. We have a special guest this week, and that's Max. And Max, how do you say your last name?
That's Desiatov.
Desiatov. See, I wouldn't have even gotten close.
This episode is sponsored by Kendo UI. Kendo UI allows you to build better apps faster. They have a comprehensive library ranging from data grids and charts to buttons and sliders. Plus, you can use their components as plain JavaScript as well as in Angular, React, and Vue. They have a large collection of customizable popular themes like Bootstrap and Material. Go check them out at reactroundup.com/KendoUI.
Now, do you want to introduce yourself real quick, and then we can dive in and talk about GraphQL and Bash on REST?
Yeah, sure. So I'm a software consultant currently working in Cambridge, UK, and I mostly focus on full stack applications using TypeScript and Swift for that. So Swift for native iOS apps, and I have a few clients who need backends for those apps and web apps. And for those web apps, I use React. And in general, the usual task is to build different APIs for the client apps to communicate with the backend. And that's an interesting experience where I started to see patterns, and especially when using different REST APIs, and wanted to publish something about it. That's how I ended up writing something about this experience and how GraphQL changed and simplified a lot of stuff for me.
Nice. Now, we've talked about GraphQL on here before, so let's just get a really brief overview of what it is. And then what I'd really like to talk about with this is, it sounds like you made some transitions from REST to GraphQL, and I'm curious how that went.
In terms of transitions, there are different ways you could approach one. Specifically, one of the examples is I have a REST app built with, the backend was built with Node, and specifically I used at that time Sales.js, which automatically builds REST API from blueprints. And if you use their ORM, when you create let's say a model, it automatically creates a table in the database and automatically creates let's say an endpoint for that model. And you end up with a lot of different interesting use cases like validation, pagination, and stuff like that. And especially with those edge cases, it gets a little bit complicated. So on the client side for that, I used Redux. And so also transitioned through different stages of trying different libraries and wrappers around Redux, like Redux Saga, and there are different tools for promises and stuff like that. But by that point, I already heard about GraphQL, and it really seemed like a good fit. Like it could solve some of the problems I had with relationships or some of the validation things, some of the validation bugs that I stumble upon frequently. So as that application, it already used Redux. It already used TypeScript. Apollo seemed like a good fit. I especially liked the fact that Apollo, at least at that time, they stated that explicitly it was built on top of Redux. And it was quite a good fit in terms of I could rewrite components one by one from Redux and Redux Saga to Apollo. And that's basically how it went. On the back end, I stumbled upon a great library called GraphQL, which is a middleware which automatically generates GraphQL schema from your Postgres schema. And so the only thing I needed to do besides that is to switch from Sales.js slowly from their ORM to attaching this middleware to the Postgres schema. The GraphQL schema was generated automatically. And as soon as I was ready on the client side, I took one component, switched it to using Apollo instead of Redux, and proceeded with one component to another. And that's how first experience with GraphQL went.
So I see that as a common like migration strategy. So like with the REST API, you're defining an endpoint that like has a whole entire resource. And GraphQL, you're defining these, you could say they're analogous to a resource, but like these data types that you can query like individual fields from. So a lot of times when I see people moving from REST to GraphQL, it's like very incrementally. It's like I'll take this little piece of a resource and I'll make this available via this GraphQL client, and like slowly over time, just reduce the amount of calls that we're making to REST endpoints.
The experience with REST endpoints is really interesting. When I started working with front end, it was already REST. I don't know, like which. I didn't feel in my skin which problem REST was solving from before. People talk about SOAP days and stuff like that. So I already entered like in the REST.
I had a chill run up my spine when you said SOAP. I built that pain. REST is so much nicer.
Yes. But REST has had its pains too. Like I remember the migration that I worked with generated like 12 different microservices in the e-commerce company I was working back in Brazil. And I needed to do all that orchestration of 12 different resources, posts, gets, everywhere. Like every page load would need like 5, 6, 7 requests to the server, like with different verbs and stuff that could be parallel, stuff that need to wait for others to finish. So I know it solved a lot of problems from before. One thing that I like about REST is that like it's simple most of the times. Some APIs. There is one API that you talk about, the Dropbox API that you talk about in your Postmax that has like the custom header stuff. Could you tell a little bit about that?
Yeah. So basically, to give you a little bit of context and my opinion on this, in terms of REST in general, I think a very interesting point here is that REST is not a standard. It does not have a spec. It's just a set of conventions, especially compared to GraphQL. Well, with SOAP, I personally haven't worked with SOAP. I only know something like that existed and it relied on XML. So I wouldn't be surprised if there is a spec for that. But in terms of REST, I stumbled upon so many different implementations of pagination. Different people do validation differently. Like from every big company, even if you... one thing is when you're working in an isolated, siloed app, but when you need to integrate with different REST APIs from third parties, especially big third parties. So one of the use cases I had is integrating with Dropbox. They have their REST API documented, but even within their own API, I have not seen a single consistent strategy for encoding different parameters. So there is one REST endpoint that requires you to pass the parameters through the URL encoding. There is a different endpoint, like when you upload a file, you need to, and you have some metadata for the file, you need to specify that to encode that as JSON first and stick that into a custom header. And I understand why that's done that way, but it still clearly seems like a hack. If it seems like if REST was a spec, a well thought out from ground up, this use case could have been somehow specified. So this specific use case is that you have some binary data and you chuck this binary data into the payload, and there is no kind of room left in the payload to specify metadata. Or there are multi-part form uploads and stuff like that, which is not related to REST in any specific way, as far as I know. So they found this workaround for writing that metadata in as JSON in custom headers, which is quite interesting, but it proves the point that like there are some conventions, but you can choose not to follow them. And this is clearly obvious when you use multiple different REST APIs, especially when you consume those APIs. And yeah, in that app, this was an app using this is another app for a client which had its own REST API with its own set of conventions. It consumed Dropbox API using the whole another set of conventions and JSON metadata embedded in headers. It also consumed Google Drive API, which is REST API, by the way, which is a completely different thing and encodes fields differently, batch requests work differently. So yeah, it only proves the point that conventions can be very different across different teams, and developers then choose to follow them or not to follow them. And this makes stuff even more interesting, I'd say.
Yeah, that's an interesting point. Something I hadn't thought about is just the fact that GraphQL is a spec and has a clearly defined specification that it makes it more consistent, I guess. Granted, still people can do things in their own way. Like, so GraphQL doesn't tell you, here's the right way to do like pagination, right? So from GraphQL API to GraphQL API, maybe things like that are handled differently, but you can see some pretty vastly different things in the REST world. So like, there are like more, I want to say formalized, but maybe that's a poor term. Like, what is it? Hadios, where it like gives you like links to all your references that you're querying or whatever. So if you're like referencing a resource from an endpoint, then you also have a link to that associated endpoint. So like if you hit GitHub and you're like, getting an issue and then somebody made a comment and like that user is associated to it, like Hados would give you like a URL back to the user resource or whatever. But what that kind of looks like is pretty varied across APIs. So yeah, that can be a pain.
I agree that is, so wants to follow up on let's say pagination can be done differently in GraphQL, but at least you have you understand that pagination can be done in a trivial way by passing parameters in a GraphQL query. Let that be a page, a limit of items on a page, while with REST, even a way to encode those parameters can vary wildly across different APIs that I have seen. And these parameters need to be encoded and also validated, which also kind of reminds me of a different problem that I stumbled upon with REST APIs. Types are just not validated by default. I've consumed APIs where there was an endpoint which passed booleans as proper booleans, JSON booleans, but there was another endpoint within the same API that passed booleans as zeros and ones for some reason. It probably done some type conversion on the backend, but that was quite an interesting point. And so with pagination as well, with GraphQL, you specify page is an int, the limit is an int, and you can't just stick in something weird into those parameters. Or at least if you are using a good implementation on the client and the backend, it will complain during validation. While with REST, you will only discover that if some of the parameters were badly encoded. You will, if you haven't done client validation, you'll get something weird from the backend. And sometimes backend just ignore those parameters and just, let's say if you've, for some reason, you've put some weird symbols into a page parameter, and the backend will just not be able to parse it, but then it might just ignore it and send a different page or the default page 0. I've seen different scenarios. Well, with GraphQL, I think the workflow is a little bit more standardized in terms of it inclines developers. It's such a trivial thing as pagination to encode in a simple way.
So would you say, from this conversation that we're having, would you say that one of the biggest benefits of GraphQL is it's a more restrict set of conventions of communication? So if it's a more restrict set of conventions, that means that different GraphQL endpoints will be more or less like we'll interact with them more or less the same way?
Yes. Formally it wouldn't be an endpoint, as GraphQL uses the same endpoint. If we say an endpoint is just a single URL, yeah, you have that /GraphQL URL. As far as I understand, it is a convention to use that /GraphQL URL that you send queries and mutations to.
I'm sorry, I was talking about like if I'm interacting with like GitHub GraphQL or Dropbox GraphQL or other services, do you think that this set of constraints would lead to a cleaner experience than when we had like REST APIs that could be like very different from one another?
Yes, I wouldn't be even surprised if someone invents an extension or proposes an extension to the GraphQL spec related to pagination, which is a quite specialized case, but still it would make sense. And also I've seen some of the conventions in the different tools we use for GraphQL. So I think especially it is quite beneficial that we have this spec and implementations try to follow that spec. So if someone invents a great way to encode those parameters for, let's say, pagination, they are free to make a proposal for that spec for the community, for GraphQL community to discuss the proposal, and it could be added to the spec, and then it's just up to the implementations to follow that. And I think pagination could clearly makes some sense. It's just very trivial use case where you have a list of items of the same type and you would like to consume them, to iterate them through just a subset of that list.
I mean, I think this having a common spec is like a good solid point. But I mean, at the end of the day, the real benefit of GraphQL, in my opinion, is data modeling. So it's interesting when you think about like at a very abstract level, like GraphQL, you're modeling these types. You're modeling like a user type or user interface, and then the user has like a name and a email or whatever. And REST, you'd have that same sort of data model, right? You might have a user endpoint where you can like pass user ID, and then you get like the same data back. But REST is like giving you this whole resource, and any relationships that you need are going to be on a different endpoint. So it's a different API call. Whereas like when in GraphQL, when you're consuming the data models, the kind of view of your data models is separate from like the data themselves. So you have your GraphQL schema where you're defining your types and your interfaces, and then your queries just kind of selectively pull the things out that you need. So it's that idea of separating like how the data is defined versus how the data is consumed. I think that's the one challenge with REST is like how it's defined and how it's consumed are so like intertwined. Like sometimes you might make a decision in a REST API. It's like, we're going to add a field to this user resource, not because it's actually a part of the resource, but because for performance reasons or for ease of our clients or for whatever, it's just easier to put it here than it is to put it on some other resource. So you end up like muddling up your actual data models or your resources for client viewability reasons. And it's like that separation between what your data is and how you consume it is what I think is like truly the power of GraphQL.
Yep, I completely agree with that. There are a few caveats, though. If you have a very deep tree of fields and a few relationships, and maybe those relationships aren't very trivial, it's up to the backend to optimize that. But also it clearly makes sense to sometimes for the backend to add different queries to make them available on the schema, which are a bit more optimized. So I think it's still, in terms of iteration time, it is great. It is a great thing for clients. Something's been added to the view. You need some field to be displayed. You know it's available on the GraphQL schema. You add it there. You get it there. You don't need to go to, well, with REST, the alternatives are you make a separate REST API call, a GET request, and then you reassemble the data from these different endpoints. Or you go to the backend people if you are a front-end developer, or if you are a full-stack developer, you go to the backend source code and just add that field on the REST endpoint, or add some way, again, maybe conventional, maybe non-conventional, but way to pull relationships in different way. Or maybe I've seen some people provide a parameter on GET requests where you can specify the fields you would like to pull. But still, again, it is just conventions. You may follow them, you may not follow them. It's up to you. For that, GraphQL clearly provides a unified way. Well, still with the main caveat that you have to keep the performance impact in mind if you traverse deep relationships. But that can still be optimized with no loss in terms of it would still look to the client in the same way. Maybe you do a different query, or maybe it would be a different query, but which returns the same type. And utilizing GraphQL fragments, for example, you could reuse those fragments across different queries.
Another interesting result of this set of conventions and types and everything, that the schemas and types and these conventions that GraphQL brings, it makes it easier to make really interesting tools, right? So which tools have you been using to develop, to interact with your endpoints?
So the one that I mentioned previously, and the one I enjoy particularly, which I think transformed the way I prototype apps, especially being a full stack developer, but I think it would allow many front-end devs to just become, when they are prototyping some app, or if they would like to try something, this tool, PostGraphQL, would allow these people to build quite quickly something simple, or even build a full-fledged app, like I've done previously for a few of the clients. So if you have some SQL knowledge, you just spin up a Postgres instance, model your data in SQL, or model the data in some relational way. There are plenty of tools for Postgres that allow you to just use some user interface to add tables and columns, add them some types and validations. I think that's much easier. You don't need to be a DBA to make a nice performing little simple database. That's quite easy these days. You set up PostGraphQL, which is literally, you can use it as a standalone command line app. You only need to specify the connection details to the Postgres database. It will automatically generate the GraphQL schema from that database. Queries, mutations for adding rows to those tables, deleting rows, updating rows. It will automatically generate all of the types. It also automatically maps, if you do want to get into something more advanced. If you have a Postgres view, for a use case here, for example, if you have some different relationships, and this query just automatically generated query, because those queries, SQL queries, are generated by PostGraphQL automatically. And let's say you stumble upon a query that doesn't perform well, you can create a view on Postgres side, which pulls different data from different tables in an optimized way. You can literally handwrite the SQL query that will be executed, and you can profile and optimize it with different Postgres tools. And that view will be exposed as a query. If that's a materialized view, you can make it materialized view. It will be exposed in the same way, where materialized views are just views that are pre-computed. Functions, SQL functions and procedures are mapped automatically in the same way. If you create Postgres is an incredibly advanced database, but still open source, quite easy to use. So if you create some custom types, custom validations, you could create a table where you wouldn't be able to insert, let's say, odd numbers if the column field is integers. That's a contrived example, but you can add a lot of interesting validations on the database side, which are, by the way, can be added in a nice declarative way. You wouldn't need to write, let's say, some specialized backend code to do those validations on the backend. And those validations would be done on the database side, and you would get those custom types reflected, automatically created in the GraphQL schema. And on the client side, what worked really well for me is Apollo and Apollo CodeGen tool. So personally, I prefer to use TypeScript as much as possible, either for front end or Node.js stuff. So Apollo Code Gen can generate TypeScript type declarations from GraphQL schema automatically. So the workflow in these kind of full stack-ish apps built with PostgreSQL and Apollo is like you create a table in Postgres. It is automatically mapped to GraphQL schema. Apollo Code Gen will automatically generate an interface definition from that GraphQL schema, and you already have those types automatically generated on the client side. You only need to write a simple, or not so simple, whichever you want, a query or mutation, basically hook up the React components as needed, and you're done. Like no need to define some specific things that I had to define, but especially comparing to the way I've done it before with Redux and Redux Saga. Apollo handles a lot of stuff like asynchronous queries it provides a lot of, let's say, it simplifies a lot of that stuff. So if a query is still loading, you would get a nice updated property that it's still loading. So a lot of that asynchronous is already embedded in Apollo. I was very, very surprised by how significantly my workflow and iteration time improved, especially if you're full stack. You can do the whole iteration very quickly. Just you added a field in the SQL table, in the Postgres table, get it exposed on the front end in basically seconds.
That's really great. One other tool that you mentioned on your post and that we use a lot here at ZocDoc is the GraphQL. I don't know how to pronounce that. GraphQL with an I in the middle.
Yep. GraphQL. I call it GraphQL. I'm not sure if that's a recommended way to pronounce it.
That's right.
So yeah, here like it's so easy to just discover like stuff, like to build your query, start building there, and then like bring it to your application. That's also like really good as a discovery tool. It's really easy to start querying your server, right?
Yeah, I personally find GraphQL just a fantastic way to develop GraphQL apps. A PostgreSQL automatically embeds a graphical instance within. So as soon as, even when the simplest scenario where you spin up a PostgreSQL instance and it looks into your Postgres database, it shows you a URL which you can navigate to in your browser. You open that URL and you have a graphical instance with the schema you had in Postgres automatically rendered. So you can see fields added in the real time. PostgreSQL quite nicely does this live reload thing where it monitors the Postgres schema changes. So you've added a field to Postgres, and in GraphQL you see those fields added. And just a simply, I think, killer features in a lot of scenarios is that in Postgres, you can add some documentations to tables and columns. So, for example, even in a distributed team, let's say a backend developer or a DBA, whoever on that side, adds some comments to like this field is indexed in that way, or this column in a view links to that column. You add those comments, and PostgreSQL automatically pulls those comments from the Postgres database and attaches them to GraphQL schema, so that and GraphQL renders those comments and that documentation. So this documentation that has been written on the database side is automatically rendered in a nice way in GraphQL, and you already see the documentation within your GraphQL schema. And GraphQL, which nicely renders that.
Sounds amazing.
Yeah, that's pretty awesome. Discoverability is definitely a huge thing. Just going back down to the types thing, so kind of pulling this back to just how like it all relates to React. So at Artsy, we use Relay instead of Apollo, but I mean the same basic premise. But we use a type generator as well, right? So you have types that are generated based off of like what your query is. So in Relay, you often break your queries down into like smaller fragments, and then a component will map to a fragment. So in GraphQL, like a fragment is just like a partial of a query or something. This is an easy way to think about it. That's probably not a completely accurate representation. But what's interesting is that we'll have a React component, and in the same file below that, you can see the actual data requirements for that component. And the types interfaces is generated in such a way that when you're accessing the data in the React component, it's all type checked. So it's like, if the schema is providing a string and you're querying for that thing, and then you try to pass it into a function that takes a number, then it's going to give you an error or whatever. And that workflow has just been phenomenal, because we talked about validations earlier in our conversation. It's like, you might have a REST API point that says, yeah, I give you a number most of the time. And then, you have to have client side validation to check to make sure that's right. And, you hope that you get it right. So that can all be really, really challenging. But with GraphQL, it makes it pretty simple to define your types on the server, what they return. And then on the client, you can have a clear relationship between what your UI is and what your data requirements are. And then that whole thing can be typed all the way down. It's one of the most amazing developer experiences I think I've ever had. It's just that idea of I am confident that this type is the same all the way across the system is just pretty crazy.
This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give you full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open sourced Sentry if you want to self-host it. Use the code DevChat at Sentry.io to get 2 months free on Sentry's small plan. That's code DevChat at Sentry.io.
The other thing is, you mentioned kind of having that documentation, that level of communication, and a lot of groups have they have the back-end team and the front-end team. So if one of those teams changes the expectation, either the back-end team says, you expected a number, but now this is daytime, or something else, everything breaks. And so with GraphQL, the contract is built into the protocol, and that's really handy.
Yep. Yeah, and now I have another question about it. Is I'm working in production for a year with GraphQL, but we only work in the read side. What about the write side? What about mutations? How do mutations work?
So in either way, either you're using PostGraphQL with the mutations are automatically generated, or you have defined the GraphQL schema manually on the backend. Both mutations and queries are mapped by so-called resolvers, GraphQL resolvers, where for every field there is a resolver that gets the data from somewhere and returns the value of this field. And same for the mutation. So there are two basic types in GraphQL, embedded types. One is query, uppercase Q query, and another type is uppercase M mutation. And basically, whatever you write in the GraphQL other than type definitions and schema definitions are either queries and mutations, which actually are fields on these query and mutation basic types. And you basically have a tree of these types embedded within other types and through different fields. From that perspective, mutations map quite nicely. And by doing a mutation, you're actually querying a mutation type, and you can specify what different fields you expect in response. But as far as I understand, it is implied. Wouldn't be surprised if it is mandated by the spec, the fact that mutation changes something on the backend. So I imagine a custom resolver on the back end would update a specific field based on the parameter and return different fields. And within the schema, a mutation, for example, let's say you have a to-do list, and your mutation is create to-do item. This mutation still has a result type, which I think it would make sense in the simplest scenario to be the to-do item that you've just created. So you populate the different fields with the mutation parameters, and most likely on the client code, you'd want to query the resulting fields, maybe an ID. I could imagine a lot of scenarios when you create an item on the client, you don't have a unique ID for that yet. You get it from the backend. So usually it would make sense to populate the fields for that to-do item and get the ID for that item created on the backend so that you can store that ID or match it to the list of displayed items. And it's the same thing with updates and other mutations, deletions. But I think these mutations, now we get to conventions, and this is what I've seen. This is the convention that I've seen that PostgreSQL uses. It creates one query, let's say, going with the to-do list example. The query is get all of the to-dos. It's actually two queries: get all of the to-dos paginated, or get one to-do by ID. Then there are three mutations: delete, update, and create. So that maps quite nicely to create, read, update, delete in REST, also known as CRUD. But it's only a convention. You could create a mutation in your schema that does whatever. I would expect something that deletes, let's say, an image that's not available, some kind of file that's not available on your schema directly, or that's not available in the type. You don't have to. That it is a convention, but this spec does not specify how many mutations and how many queries you should have for any specific type. So what I've seen, sometimes I had to create mutations where I needed batch creation. So as far as I remember, or at least the versions PostgreSQL that I used, it does not create mutations for batch creation. And I had to, in some scenarios, I had to create hundreds of items at the same time. And so for that, I even had to write a custom resolver, which is still PostgreSQL. If you can't map to SQL, if you aren't satisfied with how it maps to SQL queries directly, you can still wrap a custom resolver around it. So in my scenario was to create a custom resolver for that mutation for a batch insert, where I needed to efficiently create hundreds of items at a time. And that's quite a good use case. But in general, it's just the mutations you have and whether they do or don't match your queries. We are at the stage of conventions here. The spec does not say anything about that, as far as I know.
Yeah, because one scenario I had in my previous e-commerce work was we needed to implement like a buy later feature, right, in the cart page. So we needed to like get the cart, and then we need to delete a line from the cart, and then we need to post a new resource to the buy later endpoint, and then like retrieve the new buy later list, and then retrieve the new cart and things like that. So I could do all of that with like one mutation, right? I could do a mutation which is like save to buy later with a line ID or product ID, and then it would update all the tables and resources necessary only one mutation, right?
Yep. I could also imagine some ways where you'd like to have items generated programmatically. So it could be a mutation, let's say, create test data, or create something incrementally, create from five to-do items from a template. And in terms of test data, there is also an interesting thing I have not used personally, but I know it's quite useful for a lot of people use, called schema stitching, where you have different GraphQL schemas coming from different services, and you can merge them if there are no conflicts. So I could imagine a different schema created just for testing that is not exposed for production. Having a mutation create test data in this way, or delete test data in that way. And it could be either implemented with schema stitching or some custom resolvers, and there are different approaches here.
One thing that I'm wondering about, I'm going to change the topic just a little bit. So I was working on, I have this app that I've been working on for a while. It helps me manage all of the podcast workflows and things like that. And one of the features was that I wanted to hook it up to Zapier, which is a third-party automation tool. And I looked through all the documentation on Zapier, and it turns out that I couldn't find any explanation for how to hook up a graph to their service. And so I wound up just creating a couple of REST endpoints for the couple things that I wanted at the time and kind of ran with that. I'm curious, do you find that the adoption for GraphQL is not moving as fast as people would like? Because I really love the way that GraphQL kind of comes together, especially when I'm building the app. But it seems like a lot of third-party services still don't quite deal nicely with a graph system like GraphQL.
Yeah, it depends how fast we want it to move. There are different expectations here. I'm personally surprised there are so many big companies already using GraphQL. Like some of the examples that I've checked when I was writing that article, and that was May at that point. But I've been checking some of the bigger examples, and those were GitHub, Shopify, Khan Academy, Coursera, GraphQL themselves, GraphQL.org, their website has a huge list of users. So I think I'm also finding a lot of positive feedback from developers. And I think it depends heavily on that, the adoption. The companies need to be sure that GraphQL solves the problems they have and that it improves the developer productivity. They need to be certain that their developer tools are reliable enough. And I think we are at that stage. So yeah, definitely I would love every big API to provide GraphQL instead of REST. It's much nicer to consume, and all of these, as I mentioned, let's say Dropbox and Google Drive API in some of the examples. They do provide REST APIs, but also they provide their custom libraries to consume those APIs, those REST APIs. And sometimes those libraries just use different incompatible HTTP libraries, and you get into lots of different scenarios when using those. While with GraphQL, it would be great. You just have a unified way to consume those APIs. So it's great that there are a few examples of big companies, but I think we still have a way to go where it's going to become a default way to think about APIs. I think there are a lot of examples of GraphQL being used not just for API interaction, but for some local state management. So Apollo itself provides GraphQL API for local state management. There is also, if you're into static website generators, they currently quite frequently mentioned that I hear a static website generator called Gatsby uses GraphQL for local stuff. So from within your page that is statically generated, you still pull data from GraphQL. So I think I'm seeing this upward trend. More developers become introduced to GraphQL. They understand all of the caveats. The developer tools improve. The spec, I think there are a few things that could be improved within the spec. I wouldn't be surprised if something like standard way to paginate lists would be introduced. That would help quite greatly. There are a few other caveats I could mention, quite specific and technical details. But as soon as that stuff is resolved, I personally don't know if there is a need to not to stick with GraphQL as the default nice way. I wouldn't be even surprised if some of the new generation databases, there are constantly something new popping up. So where I mentioned Postgres multiple times, but there are also new databases like, let's say, CockroachDB, which has chosen Postgres protocol as its default protocol for compatibility reasons. But I wouldn't be surprised if some, let's say, hot NoSQL database comes up and it does not invent its own custom REST API or some own custom querying language. It could use GraphQL as just the default. So I definitely see the upward trend. I don't think that the wave of skepticism that I saw initially would just make this all die down and not go anywhere. At this point, I think I bet GraphQL would win by becoming the default. The question is when. In a few years, in 5 years, maybe everyone transitions in the next few months, and because they already have this in the works, like big companies like Google and Dropbox for their APIs. These are the APIs I'm concerned by developing for them. WordPress adopting GraphQL by default would definitely be a huge thing. I've seen some third-party adapters for WordPress. Gatsby also becomes a nice way to work with WordPress as a backend. I think definitely way to go, but I think we're getting there slowly.
Yep.
It's probably important to talk about like where GraphQL falls apart though, because so it's not necessarily great for everything and for every problem. And the biggest thing that we've got to all admit is that GraphQL is complicated. It shifts complexity, right? So you're interfacing with the client is a lot easier, but how you get data on the back end, how you manage queries and resolvers and all that stuff, that part gets really complicated. And if you get into things like you're stitching multiple services together, you're trying to figure out how to do effective caching, you're trying to like solve all these problems, things that REST does well, like caching, are not in GraphQL. And then you also have to think about things like this is an arbitrary queryable like tree structure of data, and somebody can like make a really like infinitely complex query and bring down our servers. Like, how do we respond to that? So there's all these like really challenging problems. And when I first came across GraphQL, my first thought was like, this is a great internal product API. If you want to create an internal product to interact with web and mobile and stuff like that, and it's like your product and you control it, this would work great. But it's like, if it's public, what about all these other things? So as it gets more mature, we're seeing more solutions to these things. It's like, here's a good strategy for limiting complexity to queries. Here's a good strategy for like handling load and, like using data loader for caching and things like that. But like, there's still a lot of those problems that REST have had figured out for a long time, because you can just rely on a simple HTTP infrastructure that GraphQL still's got a ways to go.
To interject, the GraphQL some people have figured something with REST, and it's still a convention for them. It doesn't mean that's if right. Someone figured out caching, people who use REST still need to adopt it explicitly in their way. So yes, there are also caveats here by saying REST figured it out. It doesn't mean that it has been implemented in the spec. Maybe in some popular libraries, yes.
Yeah, I mean that's fair. I think more of what I was getting at is that the model of REST of like having a resource per endpoint makes it easier to rely on just like regular HTTP caching. And yeah, there's nuances to how that's implemented. It's just like there are, and I guess no technology is really without its drawbacks. And it's like understanding those is really important to saying, is this appropriate for the use case?
Yeah, one thing that is not trivial in GraphQL, I would love your input on that, is like really long-term APIs, like when you need like to deprecate some fields and to change some fields. In REST, you have like the versioning strategy that is pretty standard on REST. So, and I've read some posts saying that like you should just never delete forever fields in your GraphQL schemas and things like that. But those things can grow in complexity like a lot, right? So how do you deal with those situations too? And also, of course, I would like to know like what are your pain points with GraphQL too?
Yep. In terms of pain points and different technical caveats that I mentioned, some of the few that I stumbled upon. And one that really has caused some problems, like literally at least a couple of hours up to a day of figuring out. For example, there is no standard support for 64-bit integers in the schema. The stuff that you get, PostGraphQL creates a 64-bit integer. I think it creates big integer type for you, but if you haven't handled that on the client correctly, it just some of the fields that I had just not having standard 64-bit integers. It blew my mind. Why isn't that in the spec? Why are integers 32-bit by default? This is weird. So you have to be aware of that. And I think especially for something, there are a lot of cases where you would want to quite quickly you'd stumble upon where just 32-bit integers just aren't enough, or some precisions. I think maybe some different decimal fields would make sense in the spec for, let's say, currency stuff where you don't want to lose precision. And I wouldn't be surprised if people just use double for that and they lose precision, and that causes a lot of problems. Yeah, and lose money because of that, or I hope not. But these typing issues are definitely they cause some problems for me. So when you are aware of that these problems exist, you are ready for that, and you can double check it. Yet another thing I stumbled upon basically a couple days ago is dictionary types. So it makes sense to encode some things as dictionaries where you have a string key or key of an arbitrary type. We actually had it on the client side expressed quite nicely. We wanted to map that structure to the backend, and we couldn't. We had to re-encode it into an array or an array of a different pair type that had a key and a value. And there are different scenarios here, but you have dictionaries, objects in JSON. They just aren't mapped to GraphQL. This is a bit weird. And I've also seen a couple of, I wouldn't say proposals, GitHub issues on the GraphQL spec, and those the people asking about dictionaries and GraphQL support for dictionaries, those weren't addressed in a meaningful way yet. I think it would make sense to add something that alleviates these problems to the spec. In terms of the other stuff like performance and field deprecations, again, this is a good chance to complain about how versioning and removal and addition of fields are implemented in REST, because you can version REST endpoints, but in practice, again, it's a convention. I have not seen many people doing it well. And what do you consider a REST version? Do you use semantic versioning for that? Semantic versioning is the whole different headache. If you add a field, which version do you bump? Like if backend people added a field or changed the type of the field on some endpoint, do they come to you and say, oh, don't use the version 173.5, use 173.6? Or how do you bump the version? Like some of the APIs I've seen, they just use V1, V2, V3. But I would be highly surprised if they version it on that level of granularity. I think they should. In practice, it was quite frequently where even versioning during development is quite useful. Backend guys backend people changed something on the backend, didn't tell us, or they just created a new version, didn't tell us, or they didn't create a new version. Like everyone has to have this discipline to version everything consistently. So I was quite happy when I saw a deprecation directive in GraphQL, where in GraphQL schema, you can see which fields and queries and mutations are deprecated. And that's what I saw is a recommended way to handle that. If something's been added or renamed, you deprecate the old version and wait for the clients to stop using the deprecated version or use some other strategy, I guess. But there is an embedded way to deprecate things. While with versioning, I think it's also a different question. Should some kind of versioning be in the spec? A trivial way to work around that is to just implement different GraphQL endpoints. Could you use GraphQL v1 endpoint with one schema and GraphQL v2 with a completely different schema? If you're just tired of the baggage of deprecations, I could see people working around that way. In terms of query complexity, a lot of this stuff could be improved with developer tools, I think. And it would be great if those tools, for these things not to become some conventions that only some people follow, it would be great if a lot of this stuff would be either embedded in GraphQL or Apollo server. I could imagine someone coming up with something like a field cost, query cost, or something like that, a way to, in the same way you can do for SQL, you can write analyze select query or analyze insert query, and you can get a cost for different joins and stuff. Maybe it would make sense if you are doing a deep tree structure of GraphQL on the client, that you could see, yeah, if I write that query, that would run for quite some time. Or something that at least makes people aware on the client side, or makes it explicit in the schema that adding these fields or structuring your queries and mutations in a certain way makes stuff much more complicated. This is something that could be maybe something added on the spec side, or maybe added on the developer tool. We will see. I wouldn't be surprised if something like this already exists, but I haven't heard of it.
To go back to the field deprecation, I think that is a good thing to talk about with GraphQL in general. Is just that you can monitor the usage of a field, so you can tell when nobody else is using that field anymore, and then you can just delete it.
Yep. Same for caching. I definitely saw a ton of solutions for caching. I think Apollo server does something like that, and you have a bit more flexibility here. You can cache certain fields. You can cache certain queries, different directives. You can specify directives on your query. Like if you have this in cache, return that, or always fetch the newest version and stuff like that.
This episode is brought to you by TripleByte. Applying to programming jobs sucks. You have to put the right keywords in your resume, you spend hours and hours on the phone screens and take-home projects, and that's assuming the company even responds to your application. Well, if you're a software engineer, TripleByte can help. They work with over 400 top tech companies, from big names like Dropbox and Adobe to exciting startups. You do one brief online interview with them, and if you do well, you go straight to final interviews with the company on their platform. It's like the Common App for software developers. TripleByte does not look at your resume or where you went to school. All they care about is if you can code. I've helped dozens of software developers with various credentials get jobs, and this looks like a terrific way for you to get in and get interviewed and get a job without a lot of the hassle and overhead. You can go check them out at triplebyte.com/react. That's triplebyte.com, byte as in 8 bits. As a special offer for listeners of this show, if you take a job through TripleByte, they'll offer you a $1,000 signing bonus.
Let's do some picks. Justin, do you want to start us off?
Sure. So I've got one pick at least. At work, we have a lot of dependencies, a whole lot of node module dependencies or whatever. So I was looking for a good way to help us keep some of those up to date. And I stumbled across a tool called RenovateBot. A lot of people have probably heard of Greenkeeper, which kind of does the same thing. But both of these tools, they'll open pull requests for dependencies that need to be updated. And you can merge those pull requests and you get an updated dependency. RenovateBot's cool because it has a lot of configuration that you can do. So at work, we have it scoped to only our internal packages. So anytime our internal package gets published, then all the repos consuming it get a pull request to update the version. And it's super, super convenient. Right now, it supports several different languages. One of my coworkers and I are kind of pairing to add Ruby support. So hopefully when that gets in there, it'd be a cool thing to look at. But anyway, so it's called RenovateBot. I'll drop the link. It's a lot of good. And I'm rereading The Wheel of Time, and it's a great read. So if you haven't read that before, you definitely should. That's me.
I love The Wheel of Time.
Yeah, it's so good.
I read them when I was in high school, and then I read the books as they came out, as the series ended through college and after college, because it took forever for them to come out. Typically these days I'm on audiobooks, so I have all of them on my Audible account. And when I know I'm going to be doing a whole bunch of stuff for weeks on end, then I'll typically hook up the audiobooks and I'll just listen. It takes a few months to get through them, but yeah, great stuff. I guess that's my +1 in a long-winded manner. I'll jump in with some picks here. One of them is actually the Discord channel for the shows. So if people want to jump on there, I sent an email out to the mailing list and I had, I don't know, like 30 people join this morning. So I've been kind of, jumping in and saying hi to everybody there. I'll put a link. I think I already did, but I'll make sure that there's a link on devchat.tv for people that want to get involved there. But yeah, we're having some fun conversations and just getting to know each other on there. Another project that I've been playing with lately, and it's funny because I started playing with it and then I really, really got into it and I'm spending way too much time on it. The project's called 11D and it's a static site generator, kind of like Gatsby and stuff, except it's not based on React or anything like that. I've really, really been enjoying just working on that. I kind of have a stealth project going, but we're so far ahead on this podcast that I'll just mention it. I'm actually looking at switching devchat.tv over to it. And the reason is that we update the content basically once a week per show. And so, I'm trying to figure out the scheduling on it, but the rest of it is, pretty much ready to go. So, and so I'm wondering if there's a way to set Netlify to just deploy at a certain time of day every day. And that way it won't deploy episodes until they're there, or have some script or some hook or something that will, when it goes to deploy, it'll check the drafts folder and move stuff out of there. I don't know. I'm still figuring that piece out because I don't want to release episodes early on the website, though I don't know that would necessarily be a bad thing if we're ready to go. So anyway, that's another thing I've been playing with. And the static site stuff is definitely an interesting problem to solve, but is a great solution for a lot of stuff. So those are my picks. Max, do you have some picks for us?
Yep. So my picks aren't specifically technical, although they do relate to tech. So I'd like to firstly recommend I wanted to say blog, but it's actually different notes and newsletters published by Nadia Ekbal. I shared a link. I guess it's going to be attached to the show notes. I hope I haven't butchered the name, but the URL should be very specific. So she's working on quite an interesting problem that I've been looking at for quite a while. I'm very interested into how different people approach it, which is open source sustainability. How does open source evolve? We are living in a way where open source has become so pervasive. It's basically public infrastructure at this point. Everything runs on open source. Quite significant stuff runs on open source. It's basically roads and bridges, which are we don't finance open source with taxes. But how do you finance open source? How does that work? How is this infrastructure developed? An infrastructure that benefits to everyone. And how does that work? So Nadia has been researching that for quite a while. It's her main topic, and she published a lot of interesting stuff about software foundations, how different people approach open source crowdfunding. I'm personally very interested into how big companies have, what roles big companies have in open source, especially if you consider all these different projects come from big companies who own that technology. But I'm interested and sometimes even concerned, can a small group of people that don't work to multi-billion-dollar company, can they start an open source project that's going to be used by a lot of people? And there are some examples, but then those projects still end up being owned by those big companies. So yeah, it's quite difficult, quite interesting topic, quite philosophical in some way. But yeah, I thoroughly enjoyed reading that content and Nadia highlighting the actual existence of the problem, because we use so much open source, but we don't think where it comes from. How does that work from the society perspective? And the second pick is a talk by Julia Evans. The talk is called Build Impossible Programs. So I think it's quite easy to Google. And again, the URL should be in the show notes, I guess. But it is a talk that inspired me a lot, where in this talk, Julia gives an example of building a developer tool for Ruby developers from scratch. And again, this is a Ruby profiler built in open source, and where, as far as I remember, her company gave her 3 months of paid time by that company to develop that project. Basically, TLDR of the talk, there are so many different niches in tech that some people haven't approached yet. The big companies haven't approached yet. But these problems haven't been solved. And there is some kind of barrier that prevents from other people from solving those problems. But it's still, those barriers don't actually turn out to be quite high. If you look into some niche, if you specialize in something, you quite easily can find different problems that can be solved and that can bring a lot of joy and fun while when they solve. And if it's open source, it's great. Then everyone can benefit from it. And it's incredibly motivating talk.
Yeah, we had Julia on and talked about RB Spy and how that all went. And so, definitely go and check that out. I'm curious, so do you do a lot with Ruby, or are you more interested in the open source implications there?
I had some very, very brief experience with Ruby. I do follow stuff that Julia is doing, especially she had a few articles about Rust, so I follow Rust more closely. Most of my experience is with quite a lot of stuff that I do is connected with Swift. And Swift, I think, I wouldn't say inspired by Rust, but a lot of stuff in Rust gets something in Swift somehow. Actually, I think I even saw some confirmations that some of this stuff is directly inspired by Rust. So I have this interest in all these strongly typed languages like TypeScript, Rust, and Swift. And thanks to Julia publishing a lot of stuff about Rust, I think even Ruby Spy had something. I think it was written in Rust.
Yep.
So that's how I stumbled upon it.
Yeah.
Not directly related to Ruby, unfortunately.
No, it's all good. One other thing that folks should check out if you're looking at open source sustainability, I have conversations with CodeFund, used to be Code Sponsor. I also had some conversations with Henry Zhu, who works on Babel, about the sustainability there. Because when I had the conversation with him, he was working a full-time job plus, basically doing full-time maintenance on Babel. I could talk about it for hours, but I won't. So.
Oh yeah. So short little issue. Somebody offered to take over a popular package that wasn't being maintained, and made some commits to it and everything, but also shipped some malware. So to steal people's Bitcoins. Yeah. So it's been kind of a top of mind thing. A lot of people like jumping on the maintainers, like, why did you give this away? And they're like, I've got thousands of packages and open source is hard.
Right.
So, yeah.
Cool. Sounds good. All right. Well, let's go ahead and wrap this up. Max, how do people find you online?
Mainly I publish stuff semi-regularly. I try to publish monthly on my blog, which is desiatov.com, desiatov.com. I'm mainly interested, as I mentioned, TypeScript, strongly typed functional languages, stuff that compiles to JavaScript and WebAssembly, Swift as well. I currently plan to publish something on WebAssembly and working on WebAssembly support for Swift compiler in background. So would like to write something about that. I'm also on Twitter, which is Max Desiatov, MAXDESIATOV, where I usually, again, semi-regularly post different observations on whatever is going on with Swift, WebAssembly, React, TypeScript, and this kind of ecosystem. But yeah, that's me.
Sounds good. Thanks for coming, Max.
Thank you. Thank you for having me. It was great.
All right, well, we'll be back next week.
See y'all next week.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.